So now it's time to start the real meat of the Earth Systems curriculum, and most of fall semester is all about the weather. So when you think about the weather, what's the first thing that comes to mind? If you watch the weather report or hear it on the radio or even pick up the newspaper, what's the first thing that is usually described when talking about the weather? It's going to be the temperature, how hot or how cold it's going to be that day. Yeah, I know you're concerned with, are there clouds or is it going to rain? But the first thing always expressed when you're describing the weather is the temperature. So that should beg the question, what is temperature? Now, I know you know what temperature is. Most people are going to say how hot or cold it is. But have you ever thought about what temperature actually is? Where does it come from? How is it measured? What causes temperature? Well, that's what we're going to try to explain here, because once we understand a definition of what temperature is, we can then make predictions about where it's going to be hot, why it's going to be hot and cold at different places on the planet.
So let's do a real simple short demonstration to show for us what temperature is. If you take your hands and you put your hands together and you start rubbing them back and forth, you feel a sensation. It gets hotter. That's temperature, because in simplest terms, we describe temperature as being how hot or cold it is. And you know, if you rub your hands back and forth, your hands get hotter. That's what temperature is. Now, think about if your hands aren't touching and I rub my hands back and forth, I don't get that same sensation that I call temperature. The difference is my hands aren't touching. If two things aren't touching but they're still moving, there is no friction between them. And that's what causes temperature. That's what temperature is. Temperature is a measure of the amount of friction between two moving objects. Well, how does friction affect temperature? You know that the faster you rub your hands together, the more friction you're going to have and the higher the temperatures. And if I move my hands slowly, I have less friction and hence I have lower temperatures. So temperatures are all about friction. And the definition of what temperature is that temperature is a measure of the amount of friction between moving objects.
So let's pause and have a short check for understanding, because you should be taking notes as you're watching this video. You should now understand what a definition of temperature is, and you should be able to relate movement to friction and temperature. So temperature is a measure of the amount of friction between moving particles, and the relationship is movement causes friction, and friction being measured is what temperature is. So more movement equals more friction, which equals a higher temperature. The opposite is also true. If you have less movement, you're going to have less friction and a lower temperature.
So this is a thermometer, and you know what a thermometer measures. It measures temperature. But we just described that temperature is friction. Well, I'm not rubbing my hands together here. I don't have the thermometer between my fingers. What friction does a thermometer measure? Well, this thermometer is measuring the air temperature in the room. The question becomes, what's rubbing up against the thermometer that's creating some friction that the thermometer then measures for me? The answer is air. And if we think about these two little ping pong balls being air molecules floating around the room, every now and again those air molecules come by and they hit the thermometer. Every time they hit the thermometer, that creates a little bit of friction. And the amount of hitting or rubbing or friction caused by the air that is hitting this thermometer is the measure of temperature. That's what temperature is. It's a measure of how much friction you have between objects, whether it's the friction between water molecules in a cup of water or in a swimming pool, or more commonly, the amount of friction from the air that is hitting each other and the thermometer in the room. So consider this container right here. It represents a sample of air and has a certain temperature because the air inside of it is moving around and hitting each other and hitting the sides of the container. Well, we'll use our ping pong balls to model those molecules of air that are bouncing around. And if I move the container, you can see those molecules move around. They hit each other a little bit. They cause a little bit of friction, and the amount of friction that we have between those ping pong balls is what temperature is. The question becomes, how does temperature change? How does temperature go up and then it goes down? Well, it's all about the number of collisions. Can I make these things hit each other more often? If I make the ping pong balls move more, they're going to hit each other more often, and the more often they hit each other, they're going to have more friction and temperature will go up. But what about right now? They're not moving much at all. If I just bounce it really easy, they don't hit each other very much. That means there's going to be less friction and we're going to have a lot lower temperature. So remember that the temperature is dependent upon how much air particles are moving, because the more they move, the more they hit each other. The more they hit each other, the more friction you have, and hence the higher the temperature.
Now, how fast that stuff is moving is not the only factor that's going to determine temperature. It is one of the key components, that the faster things move, the more they hit each other, the more friction they're going to have, and the higher the temperature.
So as it turns out, there's more than just how fast the stuff is moving that will affect how high or low the temperature is. Just to recap, you understand that these air molecules bouncing around in this container are going to hit each other. The more they hit each other, the greater the friction and the higher the temperature. Right now, I've only got about 3 ping pong balls in there. And they bounce around, and they hit each other, and they cause collisions. Well, how could I make there be more collisions? What if there were more air in the container? Well, now, even if they're moving at the same speed, I've got so much more stuff in there, I have a lot more collisions. And more collisions means a greater amount of friction, and a greater amount of friction means a higher temperature. So, the second big factor that determines the temperature is how much stuff is moving around and hitting each other. How much air is there? The more air you have, the more collisions there are going to be, and hence the higher the temperature.
So how can there be more or less air? The key here is gravity. Gravity works, and gravity pulls things down closer to the surface of the earth. If you drop a baseball, you know it's going to fall towards the surface of the earth. Well, air is not immune to gravity. Even though air is floating around and bouncing around, there is a lot more air pulled closer to the surface than up here. So this means you're going to have a very different temperature down low than up high, because up here there is less friction. There has to be, because there's so much less stuff bouncing around up there than there is down here. Here you're going to have more friction because there's so much more stuff. The air molecules get in each other's way and they hit each other more often and they cause more friction. So what does this mean is that you're going to have higher temps down here and lower temperatures up there. Consider this ride in an airplane. At 20,000 feet, the temperature was negative 24 degrees. That's pretty cold. Well, it's because I'm up high and there's not much air up there in the sky. But in this case, the airplane kept going up. We got up to 30,000 feet and look how much lower the temperature has gotten. Because now I've gotten even higher up where there's even less air, there's less frictions, less collisions, less friction, so there's going to be a much lower temperature. So this means that on the surface of the Earth, if you go up a mountain, it is going to be cooler, because as you go up the mountain, you have less air. and less air means less collisions and less friction, hence a lower temperature. It's one of the reasons why you tend to have snow on top of the mountains and not at the bottom. At the bottom, there's so much more air, it's going to be hotter because of the increased collisions and therefore more friction between the air. And you can see this. Take a look at this picture right here. You can tell it looks cold up here because we have snow. And right about this point right here, seems like the snow stops. Well, down here, it is certainly warmer because there's no snow down here. The snow down here has all melted because the temperature is too high. Well, the reason why it is cold enough up here for snow is because you are high enough up that there's so much less air, there's going to be less collisions, lower friction, and hence a lower temperature. You can see the point right there where you get about to 32 degrees because above that line it's cold enough to have snow, and below that line it is now warm enough because there's more air for the snow to melt. Now this also explains to us why people like vacation homes in the mountains. Historically speaking, people would build vacation homes one of two places. You'd build it on the water, especially like at the coast, or you would build these like you see here in the mountains. Well, what's the advantage of building a vacation home in the mountains? If you go back into the days before modern electricity and modern air conditioning, the cities would get really, really hot. Well, if you didn't have air conditioning and you had money and you had means, you'd want to get out of the city for the summertime and go someplace where it is cooler. And that meant going to the mountains, because as you go up into the mountains, there's going to be less air. And less air means less collisions amongst the air, which means lower friction, which means it's going to be a lower temperature. So the mountains always tended to be cooler than the closer cities. Take a look at this physical map of New York State. Remember that a physical map shows us elevation, and we can see the elevation range down here. Well, now we've learned that elevation really affects what the temperatures are. And we can see it in this map. Down here in the lower right, we have New York City. And New York City is at sea level. It is right at the coast. It has a nice low elevation, which means there's a lot of air down there because gravity pulls air down to the lowest point. And this is the average July temperature, 77 degrees, 75 to 77 degrees. And that's the combination between the daytime and the nighttime temperature. Well, that's pretty warm. Most of us are going to set our thermostats, our air conditioning, cooler than that during the day. And that's the average temperature between day and night. So imagine during daytime it gets pretty hot, it doesn't get very cool at night, and you can't sleep, you don't have air conditioning, and you want to get away from the heat. So what you would do is you would come up here. If you notice this area here, the elevation is in this range. That elevation is, looks like anywhere from 1,800 to 3,000 feet up. So you get up here in the mountains and it was going to be cooler because there's so much less air up there, up high. So mountain homes primarily were sought after because the temperature is going to be cooler in the mountains. So here's the big idea, what we've just summarized. There's less air hitting each other at higher elevations, so the temperatures are going to be lower the higher you go. That's a big concept, a key idea about where is it hot and why is it hot. But remember, the temperature, which is just the amount of friction, changes if things move faster or slower. So you have more or less air, temperature is going to change. But if the air moves faster or slower, the temperature is also going to change. So what affects how fast the stuff is moving? It's all going to be about that word right there, energy. And think about yourself. If you don't have much energy, say you didn't eat a big breakfast, you're kind of sluggish. You don't move very fast. But Give yourself an energy bar, drink some caffeine, have a sugary drink, and you get energy, and you start moving quicker, and you bounce off the walls, and you have the energy to do stuff, to move. Well, air molecules are the same way, that if you give them energy, they are going to move faster. So energy, let's define what this energy concept is. Energy, by definition, is an ability to cause change. And in this case, we're talking about a change in temperature. So to change temperature, you've got to have energy to do it. Because if you don't have energy, you can't really do anything. You've got to have energy to cause a change. Well, how does it work? If you give energy to something, it's going to move faster. Well, the faster something moves, the more friction it's going to create, because it's going to hit stuff more often. And more friction means you're going to have a higher temperature. The opposite is also true. If you take energy away from something, it's going to move slower, which is going to cause less friction, which is going to make temperatures go down. Here's one very important concept about energy, though. The law of conservation of energy says that energy cannot be created or destroyed, but it can be transferred. You can give energy away, you can take energy from someplace else, but you cannot make energy out of thin air. So, if we can't make energy out of thin air, where does the Earth get its energy from?
So here it is, a nice, hot, sunny, summertime day. So we have a very high temperature. So all this stuff is moving really, really fast, creating a lot of friction, which raises the temperature. Well, all of that takes energy. And energy can't be created or destroyed. It's got to come from somewhere. So the question should be, where did all of the energy come from to make it so hot out here today? Well, the answer is up there in the sky. All of our energy on the planet comes from the sun, because energy cannot be created or destroyed. It's got to come from somewhere. And for the most part, all energy on the Earth that determines our temperatures comes from the sun.
So we have this concept of heat. Heat has something to do with temperatures. We talk about a heater that makes you feel warm, but there is a scientific definition of what heat is that's very important for our discussions in this class. And heat is thermal energy. It's energy that goes from one thing to another, because it can't be created. It's got to go somewhere. Well, that quantity of energy that is transferred from one thing to another is called heat.
So heat is energy that is transferred from one thing to another. And we know that energy is going to change something's temperature. Well, think about heat. Right now I'm sitting in a hot car and I can feel heat from the sun beating down on my car, and it's making my temperature go up. That's what heat does, because heat is energy coming from the sun into the car and to me. And all that extra energy makes my particles move faster, which creates more friction, which makes the temperature rise. Now, we can kind of help remember this concept of heat if we think about what we have in our car, and that is this device here. This is a heater. And what a heater does is it transfers energy. It takes energy from the engine, which is out there, and brings it through the vent to me. So think about what a heater does. It makes you warm. It brings you energy to raise your temperature. So that will help you remember that heat is energy that comes from one thing to another.
Now, how that energy gets from one thing to another has only three ways in which it can happen, and that's conduction, convection, and radiation.
So the first method of heat transfer is called conduction. Conduction is when you are physically touching whatever is releasing the energy. In this case, it's the stove. And you know how a stove works. It doesn't work very well unless the pot is actually touching the burner. That's an example of conduction. If the pot isn't touching the burner, the heat will not be transferred. So once again, Conduction is the transfer of heat or energy when two things are directly touching one another. So let's revisit the concept of a heater in a car and talk about, well, how does the energy get transferred to me with the heater in my car? Remember, there are three ways in which heat can be transferred. Conduction, are you touching the heat source? 2, convection, is there some air or water bringing you the energy? Or 3, radiation, is the energy being transferred through open space? Well, if you think about a car heater, you don't have to touch this vent right here. As a matter of fact, the vent itself is not what's generating the heat. The engine out there is where the heat is. And instead, we turn on this fan and it blows air from the engine into the car. So I have the air that brings the heat or brings the energy from the engine to where I'm at. Anytime you have water or air that is moving the energy for you from one place to another, that's called convection. So once again, convection is when water or air moves the energy from one place to another, or transfers the energy from one thing to another. So this right here is a furnace or a heater in your house, and it's usually located in a closet or in a basement or in the attic. And in the case of this one, it's a gas furnace, so it actually burns natural gas and it releases energy, which can then be used to change your temperature. Well, let's talk about how do you raise your temperature using a furnace in your house. You don't have to come down here and touch this furnace in order to get hot and have your temperature raised. So the question becomes, how is the energy transferred from this furnace to you and other places in the house? So here's how the heat comes to you in other parts of the house. You'll have an air vent, and you push air over the heater in the basement or in the attic, and it gets that air hot. Well, then the air comes through the house and out of this vent, and that hot air brings heat to you and raises your temperature. So a heater in your house is an example of heat transfer by convection, because it's air that is moving the heat from the furnace to where you are. It's not conduction, because you don't have to go and touch the furnace in order to get the energy that you need to raise your temperature.
So if all of our energy on the earth comes from the sun, how does it get here? There's only one of three ways in which that can happen.
So there's the sun in the sky, the source of all of our energy that causes our temperatures here on the planet. The question becomes, how does that energy get from there down to here? Well, there's three ways in which the energy from the sun can get here. Conduction. Well, nobody reaches up there and touches the sun, so it can't be conduction. Convection is when we have water or air that brings the energy to us. Up there in the sky is the vacuum of space. There is no water and there is no air between the sun and the earth, so that can't be how energy is transferred. The only other way is radiation, which is the transfer of energy by waves, which can go through open space, which is exactly how energy gets from the sun down to us, the process known as radiation.
So another check for understanding. At this point, you should have a good definition of heat, conduction, convection, and radiation. If you don't have a good definition, rewind until you go back and find those terms in this presentation. You should also understand what the law of conservation of energy states. You should also be able to answer the question about where does the earth get the energy for the temperatures we have on the earth, and how does that energy get from the sun to the earth. So why do temperatures change? In a day, we know the temperature is not going to be the same all day long. So if the amount of air is not necessarily changing, how does temperature go up and go down? It must be something about the energy that air is getting. Specifically, nighttime versus daytime. You know it's cooler at night than it is in the day. Well, what's the difference? It's not the amount of air. You're not changing your elevation. The difference here is energy. When the sun goes down, we cut off the energy supply. And if the energy is coming from the sun and we don't get that energy anymore, things are going to start to slow down and temperatures are going to go down.
So basically everything has temperature, and something's temperature is a function of how much are its particles moving, and a particle's ability to move depends upon the energy it gets. And on the earth, pretty much all energy comes from the sun. So consider the parking lot back here behind me and the concrete. It's sitting out in the sun, it's getting energy from the sun, so the molecules here in the concrete are actually wiggling back and forth a little bit, and they wiggle more when they're out in the sunlight. Well, if they wiggle back and forth more, there's going to be more friction, and hence they're going to have a higher temperature. So if I take the temperature, right now it says 101 degrees on this concrete sitting right here out in the sun. Now, just a few feet away from that same concrete, it only registers 82 degrees. Well, it's the same concrete and we're in the same location. There's the same amount of concrete. The difference is the amount of energy that is being received by this concrete here. It's in the shade. The sun hasn't hit this part of the concrete yet, so it hasn't got as much energy from the sunlight. Its particles are wiggling a little bit slower than the concrete that was over there and out in the sunlight. So remember that a thing's temperature is determined by the amount of energy it gets, specifically from the sunlight. So if we lessen the amount of energy coming from the sun, you're going to have a lower temperature. This is why it's always cooler in the shade. This is why you would use an umbrella on a hot day and not just on a rainy day. Anything that blocks some of the sun's energy means you're going to receive less energy. The less energy you receive, the slower your particles are going to wiggle, whether it's the air under your umbrella or your body's actual particles. So anything that can block energy from the sun will result in a lower temperature, whether it's an umbrella or standing underneath a tree or a cloud in the sky that blocks the sun. The temperature is going to go down because there's less energy. Less energy means less motion. Less motion means lower friction, which that's all temperature is a measure of the amount of friction.